Okay, starting chapter 5 today. We'll start out with something that should be complete and total review, hopefully not too tough. Okay, so first, let's talk about what exactly we're doing when we graph these lines. Okay, so all chapter 3, chapter 4, we worked with lines. We learned how to graph them in chapter 3. We learned how to come up with the equations of them in chapter 4. Negative over negative is positive 5 halves x. Positive 10 divided by negative 2 is negative 5. Okay, so once we get to here, we can graph our line. 2, 3, 4. What's it? 1, 2, 3, 4, 5. Y-intercept negative 5, rise 5, run 2. Rise 5, 1, 2, 3, 4, 5, run 2. Rise 5, run 2. Or we come in here and go back, down 5, back 2. Well, I'm too close to the corner. Okay. Now, besides the fact that it makes a shape and it makes a picture, and if you grow up to work in graphics, you're going to need to be able to graph things, to create shapes. But what it's doing algebraically is that line shows every single ordered pair that if I were to plug the x and y values of them into here at the same time, that would come up true. Like, here's an example one. This is 1, 2, 3, 4 over 4 up 5. So if I went to 5x minus 2y is 10, and I put the 4 in for x and the 5 in for y, I'd get 10 just like I said I should. Okay, and we can tell some other ordered pairs that would solve this. 2, 0, if I were to plug that in, would solve it. 0, negative 5 would. This is negative 2, negative 10. This is, what's that going to be at? 6, 10. All those would make it true, but it's not just those. Those are our lattice points that work. It's whatever this point is also. So like that's 1, 2, 3, 4, 5. That's when x is 5, right? That would be like me going, okay, if I let x be 5, I could subtract 25 from both sides. Divide both sides by negative 2 and get positive 15 halves. So if x is 5, I can tell you the point that associates with that. There'll be an ordered pair at 5, 15 halves. That'll be a point on that line. Like, there's infinitely many points on that line. This actually is a graphical representation of all of them. Okay? And we also learned, without drawing a picture, we could tell if a point's on the line, if it's this ordered pair is a solution. Because we'll just do what we just tried. If I plug into 3x minus 5y equals negative 18, so 3 times the x minus 5 times the y, does that equal negative 18? It does not. Okay, so negative 2, 5 is not a solution of 3x minus 5y equals negative 18. Okay, let's try this one. 3 times the x minus 5 times the y, does that equal negative 18? It does. So 4, 6 is a solution of this linear equation. So if I were to graph this line, I know that 4, 6 would lie on it. But it's more than that. The reason it lies on it is because that pair, that ordered pair, that x and y together, make that a true statement. Okay? And then sometimes we need to talk about more than one of these linear equations at a time. And when you do that, you call that a system. So, and if you don't know, that they'll, e.g., I forget what it stands for in Latin, but we use it to say, for example. For example, here is an example of a system that I need to figure out the solutions that make x plus y equals 7, and at the same time, to make 2x minus 3y equal negative 11. So I'm going to figure out any and all ordered pairs that would be true for both of them. Okay, so first, let's just see if you can tell why it actually is a solution. So let's say we take this system. Here's an x and a y. Does it make both of them true? So if I take the x plus the y, does it equal 7? Okay, it makes the first one true. If I take 2 times the x minus 3 times the y, does it make negative 11 true? Or does it make this? So does it equal negative 11? So does it make the equation true? It does. So tell whether that is a solution. It is. So 2, 5 is a solution of this system. Okay, if I do the next one. So if I take the y, does that equal negative 2 times the x minus 4? Negative 2 times negative 2 is 4. 4 minus 4 is 0. Okay, so it makes the first one true. But here's the thing. If it's a system, it has to make them both true. So if we try the second one, does the y equal the x plus 4? It does not. So negative 2, 0 is not a solution to this system. Okay, so y'all try a couple on your own. Plus the y does equal 0. I'm just still talking because I'm hoping that you pause the video and or try it on your own. True. The opposite of x plus twice the y, does that equal negative 5? It does. So is a solution. We do this one. Here's x, here's y. Four does equal 4. Okay. The y, the opposite of x plus 5, is a solution. Good. Okay. All right. Now, if we were to graph these, okay. So x plus y equals 3. Now, this one, it's already been graphed. Let's make sure you understand which one's which. Okay, so this is the line y equals, or we can just write it the way it was, x plus y equals 3. 2x minus y is 6. Divide both sides by a negative. That's this one. And so any point on that line is a solution to the bottom equation. Any point on the one with a negative slope is a solution to the top. So what we're looking for is what is the point, or sometimes more than one point, that satisfies them both. Well, it's right there where they cross. That's the only point that makes both of those true. And that's at 3, 0. That is the solution to this system. So look at this. If I put 3 plus 0, does it equal 3? It sure does. If I do 2 times x minus y, does it equal 6? It sure does. So graphically, we can come up with the solution without having to do any algebra. It's like, oh, there's the one point that lies on both lines. That means it's the one ordered pair that makes both those equations true. Okay, so let's get this. So y is x minus 4. That's a slope of 1 over 1. Don't fake this. Actually, draw them out as far as you can, because our job is going to be to see the point that's on both. If you don't draw an accurate line, you won't have points that are actually on these lines. So did that one in blue. I'm going to do this one in gray. Oh, no, green. I thought I picked gray. So slopes -1 over 1. So I'm going to do down 1, right 1. Now the whole thing I'm doing here is hunting the solution of the system. So I'm not going to draw that one as far as I did the other, just because I didn't know where these two lines would cross when I drew that first one. I can see where they're crossing here, and I realized that what I'm looking for is this. I'm solving the system. To solve the system, I'm finding the point where they cross, which is over 3, down 1. That's like the graph just tells me the solution. But this is the answer. Okay, so if I do this one, -3, I'm going to rise 1, run 3. Okay, let's swap colors and do the other one. Let's do the black one. So y-intercept of 3, go down 2, right 3, down 2, 1, 2, 3, right 3, down 2, right 3. Right there at 1, 2, 3, 4, 5, 6, down 1. That's the solution. And I can check. Is -1 a third of 6 minus 3? A third of 6 is 2. Yeah, yep, it is. Is -1 -2/3 of 6 plus 3? Let's see, a third of 6 is 2. That's -4 plus 3. It is. I know I'm right. Okay, so this one. Do the first one in black. So 1, 2, 3, 4, 5. I'm going to go down 2, right 1. Or up 2, back 1. The other point. That's y-intercept -1. I'm going to rise 4. 1, 2, 3, 4. Run 1. 1, 2, 3, 4. Run 1. So the system is solved by the point 1, 3. That's the one point that's on both lines. And see, look, we can check. 3 is -2 times 1 plus 5. It sure is. 3 is 4 times 1 minus 1. Sure is. Okay. And then sometimes we're not going to have to graph these because you only know how to graph a line. And that's all you're going to learn how to graph in Algebra 1. We're going to graph a line, we'll be done with it. But this whole idea, it kind of, you can do it. There's other things that we can end up graphing in math. So here's a line that crosses, this shape's called a parabola. Whether you know the equation or not, it really doesn't matter. We can come up with whatever the equations of these two are, which, I mean, we could get them. Well, you could get the equation of the line. You can't get the equation of parabola yet, but you'll learn how to do that in Algebra 2. But I can tell you this, what solves the system. This point right here is -1, 1, 2, 3. This is -1, 4. And this is -3, 3, -8. So the system gets solved by these two ordered pairs. And I didn't have to do any work.